Normal distribution. The normal distribution is the most widely known and used of all distributions. It looks like a bell shape. It is symmetric around the mean, which is the middle part of it. The first deviation, right and left, would make 68%. The second deviation, right and left, would make 95%, and the third deviation would make 99.7%. Now, in order to know how do I get the percent I want, we first convert the problem into an equivalent, one dealing with a normal variable measuring in standard deviation. In order to get this standard deviation variable, we say that the z here is equal to x minus mu over sigma, which is a number less than from 0 up to 1. A table of standard normal variables. That is the table we're going to use here, which is the table of the z values. Remember, if necessary, we can then convert back to the original units. Let us take an example for that. A professor's exam scores are approximately distributed normally with mean 80 and standard deviation 5. Now I have my mu to be 80 and my standard deviation to be 5. What is the probability that a student scores an 82 or less? According to my rule, z equal x, which is the amount you have, which is 82, minus mu, which is your mean, divided by your sigma, which is the standard deviation. You get your answer to be 0.4. What are you going to do with this 0.4? You're going to go to your table here and look for the z, which is 0.4. It doesn't have anything next to it, so 0.4.00. My answer is 0.1554. That is my answer here. But he says or less. So I'm going to take all the part less than from my table here, from my bell shape. If 80 is here, then 82 is on this side, and I'm going to have all those who are less than the 82, which means I'm going to add to my answer the 0.5, which I did here. So the total is 0.6554, which is 65.54%. Next question. What is the probability that a student scores a 90 or more? 90 minus 80 divided by 5, I get 10 over 5, which is 2. So I'm going to get my table. Now I'm going to look for a 2. Where is my 2? Here it is. 2, which is 0.4772. What did he ask me for? He said 90 or more. According to this table, 90 is after the 80, and or more would be only this part. The part I got from my calculations is from the mean up to the 90, which is the 0.4772. He said or more, so I need to take the last part. So it is 0.5 minus 0.4772. So my answer is 2.28%. The third question. What is the probability that a student scores a 74 or less? Z equals 74 minus 80 over 5, which is negative 6 over 5, which is minus 1.2. Again, I'm going to get my table. Of course, my table does not contain plus or minus. It only contains a number. So it is 1.2. I'm going to look for 1.2, which is 0.3849. I'm going to put my answer and then subtract it from the 5 also. Why? Because according to my table, it is this part, or less, or less. So I'm going to have 0.5 minus 0.3849, which is 0.1151, which is 11.51%. Now, what is the probability that a student scores between 78 and 88? I'm going to get the 78, which is minus 0.4, and get it from my table, which is 0.1554, and then the Z for the 88, which is 1.6. And I get it also from the table, which is 0.4452, and then add those two values to get the amount between those two.